our first lesson trying to apply some biomechanical principles. We're going to use this guy as the basis of what we're looking at today. So for those of you that don't know, it's Isaac Newton. We're going to apply basic mechanical principles and physics, which is fundamentally what biomechanics is, to analyse movement. And by allowing us to do this, we can start to understand performances a little better. If we can understand them and we can analyse them, we can maximise movement efficiency of athletes and teams or whatever it is that we're working with. Therefore, if we're more efficient, we're less likely to get injured. And if we can understand how things move, perhaps actually we can continue to design equipment using technology, which we'll look at a little bit later on, to help us become more efficient. So this guy, he had 3 laws. He designed 3 laws or physical laws that are used to show the relationship between a body, that's usually an athlete, or it could be a piece of equipment, or it could be a projectile. So it's the relationship between the body and the forces that act upon it, and therefore the motion that is caused about it, okay, or caused by it, apologies. So the body, the forces, and then the motion. All right, and what we're going to look at within these 3 laws is actually what the forces are, what impact it has on that body, and the motion that is caused by it, or the changes in velocity that is caused by it. A very simple way, and I have to thank a year 13 student from quite a long time ago, a very simple way of remembering this is to think about Ian. So when you think of a person called Ian. Now this will help us to remember the laws and the order of the laws that they go in. All right, the last one is a little bit tenuous, but we'll go with it. So I, first letter of Ian, stands for inertia. All right, so the first law of motion. A will stand for acceleration, the second law of motion. And then N stands for reaction. This is where it's a bit tenuous, but it ends in N. So if you can remember the first 2, hopefully you can remember reaction as the third one. All right. So Newton's first law. Now this, you need to know two definitions for this one. You need to know that it's the first law. You need to be able to state what that first law is, but we also need to understand the concept of this word inertia, because it's a little bit confusing when we try and apply it. Okay, so his first law: a body will continue in a state of rest or uniform velocity unless acted upon by an external force. All right, so velocity is measured in meters per second, and that could be that the body is still or the body is moving, but it's at a uniform velocity. Okay, so the bodies in this pictures, we've got on the top right hand side, we've got a football, we've got a sprinter underneath them, and we've got a runner, so we've got Mo Farah there as well. So we can use these pictures to all demonstrate the law of inertia, and you may well be asked in your exam to actually apply the law of inertia to any number of different objects, okay? Or you may have to choose an object from your own sport that you play. When you do your analysis and evaluation work, you will actually have to apply Newton's laws to your own analysis of your performance that you're watching, okay? So we need to think about what's going on with these objects at the moment. All of these athletes have gravity acting upon them, all right? That is pulling them down to the ground. Okay, if I just let's just move around, let's add some arrows onto this. So they all have gravity in this football demonstrated by that yellow arrow. We've all got gravity pulling us down to the ground, all right? That turns our mass into a weight force. So the law of inertia recognizes that the greater the mass, the greater their inertia is. So another definition we really need to know is that inertia is the body's resistance to change its state of motion. So if we were to look at that football, we know that football is very light. Sometimes you see when football players are lining up to take their penalty or setting up to take a penalty, in high winds, you can see that ball moving off of the penalty spot. It doesn't take very much in order to change that football's state of motion. A very, very small touch on that will cause that ball to move or change that motion, change that velocity. All right. If we think about the sprinter, So you can see that our sprinter, that arrow is not quite in the centre of mass, so apologies about that. But we can see that that sprinter has got a heavier mass than the footballer, than the football, and so therefore it's got a greater inertia. Okay, so he will need a greater force applied to him to accelerate him out of the blocks or change his state of motion. He is not going to move because of a bit of wind pushing past him. Okay, he's going to have to apply a large amount of force into those blocks in order to allow him to accelerate out of that blocks because he's got a larger inertia. Okay, let me just pop his other reaction arrows. Just to note that these red arrows, what they are demonstrating is the reaction force. So when we look at Newton's third law of reaction, you'll notice that every force has an equal and opposite reaction. So in these instances, we're looking at the changes in velocity, and we're looking at the balancing of these forces. All right, we'll talk about that just in a second. So if we then take Mo Farah here, he is running at a steady state of motion. We're going to presume that he is. We can't really tell from this picture because we can't see him moving, but we're going to take this as an example that he is moving at a constant velocity. Okay, he's maintaining his velocity by the forces of his muscles acting on the ground, and they are balanced against what's known as the air resistance acting against him. Okay, he's obviously lighter than our sprinter, so he's got a lower inertia. All right, but he's obviously heavier than a football, so he's got a greater inertia to that of the football. But because he's lighter than the sprinter, it actually makes it easier to change his state of motion. So you can think about this as it being easier for other people to barge him off of the track or out of the way. If you think about when athletes are kind of bundling together, it's easier for him to be decelerated or change his motion by somebody kind of knocking into him. But also it means it's easier for him to decelerate as he crosses the line. It's also easier for him to put in a kick to help him accelerate away from the group, which you often see him doing in the races. So in all of these examples, we can see that they are at constant velocity. Okay, constant velocity could mean that they are still, they are not moving. It could mean that they are moving at a steady pace. But what it fundamentally means is there is zero net force. All of the objects and all of the forces acting on those objects are zero. All right, so the weight force acting down from the football is equal to the reaction force acting up. The sprinter, the weight force acting down into the ground, is equal to the reaction forces acting up on his 4 points of contact there. And Mo Farah, we're using the horizontal forces here as an example, that his acceleration, his friction force, as we'll call it later on, is equal to that of air resistance. Okay, so that means that these objects are staying in a constant state of velocity until compelled to change by an external force, whatever that external force will be. And we will link that in shortly to that of the law of acceleration, so our second one. So just to summarize, please remember the word Ian, so inertia, acceleration, and reaction. And then remember also that the mass of an object will directly correlate to how much inertia that object has. So you need to recognize that the greater the mass, the greater the inertia. And inertia is the resistance a body has to change its state of motion. Okay, I hope that makes a little bit of sense, and we'll look at acceleration shortly.